Professor Muhammad Asari from ITS.
Hello, good afternoon. Can you hear my voice, Mas MC?
Yes, sir.
Okay. Okay. Good afternoon, ladies and gentlemen. Thank you very much and welcome to ISITIA. The Honorable Chair of this conference, Bapak Profesor Sudipyo. The Honorable.
Dia udah confirm kok.
Oh.
Tadi email saya dikonfirm oleh beliau.
Halo, ini bocor ya. The Honorable guest speaker, Professor Arai from Japan, and also my colleagues from Curtin University, Professor Ahmed, Abu-Siada. Welcome to our conference, International ISITIA, and all distinguished guests, all distinguished participants. Thank you very much for attending our conference. Even this is in online system, but I think we're still happy and we will get everything, including sharing knowledge and experience. Ladies and gentlemen, we know that ISITIA is a conference hosted by Department of Electrical Engineering of ITS in Surabaya. And ITS, as you know, this is a public university that established in 1960. And then in the next 3 months, we will have a 62nd anniversary. So I think this conference is also a part of the anniversary of ITS. Ladies and gentlemen, Bapak Ibu semuanya, terima kasih atas kehadirannya, especially for our guests, distinguished guests, Professor Arai and Professor Abu-Siada. We have had collaborations since a long time ago with Professor Arai, especially when ITS, we have a project in research and education, especially in ICT and ITS in 2006 until 2020. So Professor Arai, thank you very much for coming in our conference today. Also my colleagues, Professor Abu-Siada, thank you very much for coming, for joining us. I know you also the speakers in another conference held by ITB that I also as a committee in there. So again, we appreciate for your sharing knowledge with us. So on behalf of ITS, I would like to thanks to all the participants, to the committee, and also all the senior leaders of ITS, including the head of department, Pak Dedet, and also the Dean of Electrics, and all the senior leader of ITS. So again, appreciate and thank you very much. Happy conference, ISITIA. See you and good afternoon.
Thank you very much, Professor Muhammad Asari.
We will continue to the next agenda, which is the keynote speeches for today. Each keynote speech will have 30 minutes for presentation part and 15 minutes for Q&A or question and answers part. The audience can ask the question via chat or comment section or use the raise hand feature during the Q&A session.
For the first speech, we have Professor Ahmed Abu-Siada from Curtin University. As the moderator for this speech is Dr. Dede Chandrariawan. Ladies and gentlemen, please welcome Professor Ahmed Abu-Siada and Dr. Dede Chandrariawan.
Good afternoon, everyone. This afternoon, for the first keynote speaker, it will be delivered by Professor Ahmed Abu-Siada from Curtin University, Western Australia. And the topic of his speak will be frequency response analysis, an enabling technology to assess mechanical integrity of power transformer. Before we listen the presentation, please allow me to read the short biography of Professor Ahmed Abu-Siada. Professor Ahmed Abu-Siada received the BSc and MSc degrees from Ain Shams University, Egypt, in 1998. And he received PhD degree from Curtin University, Western Australia, in 2004. And all degree is in electrical engineering field. Now, Professor Ahmed Abu-Siada is a full professor and head of electrical and computer engineering discipline at Curtin University. His research interests include power electronics, power system stability, condition monitoring, and power quality. And he has published over 300 papers and articles in this field of research. And also, he is a chair of the IEEE Western Australia section. And also, he is a founding editor-in-chief of International Journal of Electrical and Electronic Engineering. And also, he is a regular reviewer for various IEEE transactions. Okay, without further ado, I would like to invite Professor Ahmed Abu-Siada. Professor, time and room is yours, please.
Thanks, Dr. Dede. Can you hear me?
Yes, it's very clear.
Okay, I'll just share my presentation. Can you see my screen now?
Not yet. I cannot see your screen. Maybe from organizer can help Professor Ahmed.
So just to give me permission, please. I think I need a permission from you to share my screen.
I think you already have the permission, Professor Ahmed.
I don't know. I see it says here I don't have permission to share it.
Oh, okay. With a moment, Professor, I will resolve this problem with the organizer. Maybe anyone from organizer can help the sharing screen feature. Professor Ahmed, I already seen in the list of participants. You already has the you already have the permission to share screen.
So you can see now my screen now?
No, we cannot. Or maybe you use a double screen or extended screen maybe. So maybe you can switch to the duplicate mode of your screen, so we can see exactly what on your screen.
Connect one. How about now? No, you can't?
No, not yet. Or maybe Professor Ahmed, would you please maybe send your presentation file, and then the organizer will present. I mean, will put in the computer.
Yeah.
Yeah. Okay. I think Professor Ahmed Abu-Siada just disconnected from this room. I think can from the organizer check the presence of Professor Abu-Siada.
Yeah, I think you can see now my screen.
Okay, now yes, we can see your screen now. Yes, yes.
Yeah, sorry, I had to log out to allow myself to join the meeting.
Yeah.
So if you are seeing it, I think without any further delay, I can start the presentation.
Yep.
Is that okay?
Yes, sure.
Okay, so let me just put it in the slide mode. Okay, good afternoon, everyone, and sorry about the delay. Thank you very much for inviting me to deliver this speech about power transformer. I would like first to thank the organizing committee, the head of department, Dr. Didit, and of course, Professor Arai for inviting me to deliver this short speech. The speech is about power transformer, and as you know, that power transformer is a very important piece of equipment in any transmission or distribution network. Any fault happens within the power transformer, it will not only lead to a lot of cost and loss of revenue due to business interruption and the stop of the power supply, but it may result in catastrophic failure, including fire, oil spillage, and environmental hazards, like what you are seeing now, which happened in many places around the world. The power transformer itself is a very complex piece of equipment, which has many components, including the winding, active winding, low voltage and high voltage winding, the bushing, tab changer, which is the only mechanical part in the transformer, which changes the turns ratio between low voltage and high voltage, and the insulation system, which has paper to keep the mechanical integrity of the transformer, and oil. According to a recent survey conducted by a Saga working group, they found that about 38% of transformer failures is attributed to the winding of the transformer, low voltage winding and high voltage winding, followed by the mechanical part, which is the online tab changer, and then the insulation system and bushing. So it is very important to keep eye on these components and these parts in the transformer. And if there is any fault we can find during the maintenance or during the condition monitoring, we have to rectify it as soon as possible to avoid catastrophic failure like the fire you have seen in the previous slide. So researchers and industry experts came up over the years by various diagnostic techniques, which can be categorized into chemical techniques, electrical methods, mechanical methods, and some special testing. And each of this technique is responsible to find the condition, health condition of the transformer from certain aspects. For example, the frequency response analysis here is responsible to detect any mechanical deformation in the core or in the winding. As you know, we don't have window to look inside the transformer and see what's happening inside. So frequency response analysis is one of the techniques that can discover the mechanical integrity of the transformer externally. Okay. A common challenge now in all of these techniques is the cost of monitor. Some of these techniques are very expensive. The reliability of electronic equipment. You have some sensors that you should connect to the transformer in a harsh environmental and operating conditions. You have very heavy electromagnetic field in the substation, background noise, high voltage. So how can we assure and guarantee the reliability and the accuracy of the equipment and sensor we are using? The performance of the sensor also under such harsh environment. And also the main challenge here is some of these techniques must be conducted offline. You have to take your transformer out of service, which will cause interruption to the power supply. So can we come up with online techniques? That's the main challenge in either research or in industry practice. So today I will only talk about one technique because of the time constraint, which is the frequency response analysis. In my talk, I will go through the principle first, the current industry practice, the challenges in the current industry practice, and how, as researchers, how we can overcome such challenges. That will be the scope of my talk today. So back to the principle, we know that the power transformer, including the core, winding, and insulation system, can be represented by equivalent electrical circuit. And this circuit will comprise resistive component and inductive component, representing the main winding, which is from copper or aluminum, and the insulation system, which is paper and oil, will be a capacitor and conductance. So that's the equivalent circuit of the transformer in high frequency domain. That's one disk or one turn only. So I put some animation here just to follow me. We start by the low voltage winding, which can be represented by a series inductive elements, R and L. And because this winding has insulation paper between them, so the insulation paper can be simulated as a dielectric capacitor shunted by dielectric conductance. Similarly, we have the high voltage winding, which can be represented by inductive elements shunted by dielectric capacitance and conductance. You know, in transformer, we have first the core, then low voltage winding, then insulation, paper insulation and oil, and then the high voltage winding. So between the low voltage and high voltage, we have paper insulation mainly, and oil going in ducts, which can be represented by capacitors and conductors. Between the low voltage winding and core, when we wind the transformer, we start by the core, then low voltage winding. But between low voltage winding and core, of course, we must have insulation, that's varnish on the laminated steel, and paper insulation. Again, any insulation can be represented by a capacitor. And all of these windings are immersed in oil. So the oil can be represented by a capacitor and dielectric conductance. So that's the equivalent circuit of a simple disk or turn. Okay? Frequency response analysis came from this equivalent circuit. We have capacitive component, we have inductive component, which is our frequency dependent. Remember, XL equal omega L, XC equal to 1 over omega C. So any variation in the transformer winding, whether the transformer is moving up, down, on the right-hand side, on the left-hand side, due to any reason that I will explain later, that will affect the capacitance and mutual and self-inductance, right? If, for example, refer to the basic formula for capacitance, epsilon A over D. So if you change the distance between two terms, that will change the capacitor. And that will affect the spectrum, the spectrum, frequency spectrum of the transformer. That's what we call frequency response analysis signature. So the technique, the measurement itself is very easy and simple. Anyone can do it. But you have to take the transformer out of service because you have to scan the transformer in right frequency range. You can't perform the test at the power frequency, 50 or 60 hertz. You need to detect inductive components, which can be detected at low frequency range, as well as capacitive components, XC equal 1 over omega C. That would be detected at very high frequency. So the typical frequency range for the test would be from very low frequency, like 10 hertz, to very high frequency, 2 megahertz. And that's why you have to take your transformer out of service because you need to inject variable frequency to the transformer. And then you scan each phase of the transformer, phase A, phase B, phase C, with this small device. The device is called frequency response analyzer, which injects very low voltage, 10 volt only. But the voltage here is of variable frequency from 10 hertz to 2 megahertz. And you measure the impedance or admittance or the transfer function of each phase against the frequency. That's called the frequency spectrum or characteristic of each phase. But again, back to the normal, what we expect when we measure, how the signature will look like. Back to the fundamentals, if we have RLC circuit, you know that XL, the inductive reactance is a straight line, omega L. The capacitive reactance is 1 over omega C. And if they are equal at a certain point, that will give us a minimum impedance, which we call a resonance or resonant frequency. And the corresponding angle will change from minus 90 to 90 degree, representing the inductive and capacitive effect, right? On the other side, if we have a parallel branch of RLC circuit, that's the susceptance 1 over X for the inductance and 1 over XC for the capacitance, capacitive susceptance. When they are equal at a certain point, they will give us maximum impedance, and that's called anti-resonance frequency. Also, the angle here will be from plus 90 to minus 90, reflecting the effect of L and C. So what do we expect if we have very complicated circuit? I showed you only one disk, the equivalent circuit of one disk. If we have multi-disks like this, of multiple series and parallel branches, we expect multiple resonance and anti-resonance points. And that's what you will get in practice. You will get a signature like this. The x-axis here represents the frequency from, as you can see, 10 hertz to 2 megahertz. Y-axis here could be impedance, could be admittance, or could be transfer function, as in here in dB. And what you are seeing here are the frequency response of the three phases, phase A, phase B, phase C. So when you measure it, what to do with this? We have to compare it with the fingerprint. So ideally, when we have any transformer installed for the first time, we have to measure the frequency response analysis, and we call it a signature, fingerprint, like your fingerprint. And then in the future, if we suspect that the transformer has something wrong inside, in the mechanical point of view, we have to compare this signature with the previous one. But for all the transformers, especially in Indonesia, we don't have a fingerprint because the technique is relatively new. It's about 10 years old or 15 years old. So for all the transformers, when we don't have the fingerprint, we can just compare the three phases together, because we expect that the three phases are identical and will give us a similar response. So if you look here at phase, the white, yellow, and the blue, they're almost the same in the high frequency range. Maybe in the low frequency range, one of them is a little bit different, deviated to the left of the frequency response. And this one is the middle phase, phase B, which has different flux, magnetic flux, than the outer limbs. So this one is normal. And we can say that this transformer is healthy, nothing wrong with it. But when you look at another signature, this one here, of course, here, even if you don't have any experience with the frequency response analysis, you will observe that one of them is significantly deviated from the others in the low frequency range, which means that this transformer has something wrong in this phase. So what we have to do is to take the transformer out of service and unwrap the winding. So the suspected winding was this one here. So we have to take it outside to the workshop and take the papers out, unwrap it. Look, when we started to unwrap it, we found carbon tracking here spots, which means something happening inside. There's a sustained arcing or partial discharge underneath. And when we complete the unwrapping the winding, we found that was the static shield of the high voltage winding was loose. And that was the cause for sustainable arcing or partial discharge. The transformer looks normal and was working normal during the operation. But if you leave it, you may end up by having fire. If you don't notice that there's something wrong like this arcing or sustainable arcing may lead to fire, catastrophic failure. If we look at another example, this transformer, you know now the three phases here are similar to each other. The one to the left here is the middle phase, which is normal. So this transformer is healthy, nothing wrong with it. But if you look at this one, we have significant deviation among the three phases of the transformer, which reveals significant problem here in at least two phases. So when we took the transformer out of service, I don't think you can observe. Can you see that this very strong electromechanical fault happened inside the transformer? You know, when we have a short circuit fault, the short circuit current can interact with the leakage flux, phi, and cause electromechanical force that may cause the transformer to move down, or to have buckling like this, forced buckling. You can see the buckling here. That's a huge force. If you don't see it from there, I highlighted it here, but you can see it from inside. That's inside view. You can see it in here. Again, with such kind of fault, the transformer will look normal. You won't see that. But suddenly, if you don't notice that, you may lose your transformer, and it may lead to catastrophic fire. So that's the problem of such kind of faults. So what's the challenges in this technique? As I told you, the measurement is very simple, very easy, and anyone can perform it. But the technique is so far offline. So we have to take the transformer out of service, which will cause interruption to your grid. That's from the measurement point of view. Also, this device here is not very reliable for minor deformation. So when you have emerging faults such as started with very minor level, that device cannot detect it. So we have two problems. The first question is, as a researchers, can we come up with online technique? And the main challenge here, how can we have variable frequency up to 2 megahertz while your frequency in Indonesia is 50 hertz? The transformer must work at the power frequency, which is 50 hertz. That's the first question. Second question is, can we increase the measurement reliability and the accuracy? That's the second question. And that's a good field of research for guys who are studying at any university. Also, from the analysis and interpretation, you may have noticed now we are relying on graphical interpretation like this. So yes, we can tell that something wrong, but what's the kind of fault, location of fault, type of fault, level of fault? That's the main challenge here. We don't have standards and codes for automatic and standard interpretation. So that's another challenge. But today I will just, because of the timing, I will only talk about the first challenge, the measurements, and whether we can come up with a new device that can measure it in real time or not. So that's the question I'm trying to answer in the next few slides. Is it possible to come up with online technique? The first one is, okay, what I need variable frequency. And we know that if I have lightning or thunderstorm, lightning has impulse signal like this. And this signal, mathematically, for those who are good in mathematics, is a difference between two exponential functions, which if I transform them into frequency domain, I will find that it contains a lot of frequency that will be enough to draw and plot the frequency response signature. So the first thought from researchers is, okay, if now I have a transformer in operation, and I'm in a place like Florida. Florida is famous by hurricanes and lightning and thunderstorm. Can I use the natural lightning as a source of frequency response analysis? So I will not connect anything, but I'm using the natural impulse coming from the environment. Some other people, like in Indonesia, if you don't have lightning, you may have a switching operation during transit. If you are connecting a capacitor or taking one load shedding, that will cause a transit in the system. And during transit, you will have impulse function or wave propagating in the system, including the transformer. Can I use it to plot the FRA? People in industry in Florida started to think about that, and they thought about this transformer, that's auto transformer, which with tab changer here, high pass filters, and they bought their devices and measurements and scopes in here. So they didn't connect anything, they just connected their scopes, and they tried to use the natural lightning impulse as a source for the FRA. So they don't have to connect it to external source. And they were successful to do that. Look at this one here. That's one phase only, by the way. What they draw here is the amplitude of the admittance against frequency. And this frequency is not coming from external source, artificial source. It's coming from environment because of lightning impulse signal. And they plotted it twice in 2 different weeks, and they found that this phase is healthy. By the way, this one here is the angle from minus 90 to plus 90, and this one is the coherence or correlation coefficient. They also changed the tab changer. Remember, online tab changer, that to change the turns ratio. So they changed it and they measured it on tab 1 and tab 2, and they found that yes, that it can detect the changes in the turns ratio. However, this technique is not very practical. For example, in Indonesia, you don't have lightning that much. You don't guarantee that lightning or any signal coming from natural switching operation will have enough energy or enough frequency components to plot the frequency response analysis signature. So this one is not practical and is not implemented anywhere. It was just an idea from this company. Some other people said, okay, how about if I connect during the transformer operation, I can connect an impulse generator. I need only maybe 1 kilovolt or 500 volt for a few microseconds. So can I connect it to operating transformer and for each phase and plot the FRA? So what they did, they connected impulse signal like this through impulse generator, and they measured the impedance again, or admittance, or transfer function against frequency. And we have done some of work, like we used this one here, which is a pulse generator. We connected it to the transformer, and we found that yes, it can plot the FRA. So what you see here is what we did using the impulse generator and the signature due to the small device offline test. So they are identical. So this technique can be very practical and can be used for operating transformer. We did a lot of work on that and to find out if we can detect all types of faults. So if you look here, we created short circuit winding. We created also what's called axial displacement. I will come to this point later, what axial displacement is when the winding moves downward. And we created, you can see it in here, that's called buckling in 1 degree or more than 1 degree. And that's short circuit, how we created a short circuit. We just basically, simply we short circuited some turns here. And through this technique, we could detect the fault, okay? But again, the question is, that's how we implement it in real time. We can measure the voltage through capacitor coupling sensor and the current through Rogowski coil. But the issue is no one like PLN in Indonesia may not allow you to inject a voltage of 500 or 1 kilovolt to their transformer, operating transformer. Even if the voltage here is for a few microseconds, they will be reluctant. So the feasibility of this technique, again, is a question. The last point, I know I may exceeded my time, but it's only 3 or 4 slides. The last point is, okay, how about if we work a power transformer? I mean, can we just exclude the frequency? So we are not looking here at a spectrum of very high range of frequencies. I will perform the test at 50 hertz, and I will draw it. I'll do it through measuring the voltage and the current of the transformer. The advantage of this technique is you can perform it at the power frequency, 50 hertz. So there is no need now to use external source or to disconnect your transformer. The other point is you can do it every cycle, which is 20 milliseconds if your frequency is 50 hertz. So what the idea here came to me from this simple equivalent circuit of the transformer. You may notice that there's no capacitor here because I don't have high frequency. I will perform the test at 50 hertz. At 50 hertz, the capacitor is almost open circuit, right? 1/2 pi FC. So that's the phasor diagram we all know. And what I thought about is I will plot a phasor between V1 minus V2. That's the voltage difference between the input and the output of each phase against input current. Mathematically, that will be an ellipse. So when I plot the voltage difference of each phase against input current, will be an ellipse like that. So my thought was, can I use this ellipse as the fingerprint for each phase? And if I have any deviation from this, either I have bigger area or rotated ellipse, can that be an indication for a fault? So that's a graphical illustration of the technique, very simple. All what I want to do is to measure the difference of the voltage against the input current. So in each cycle, so for each one cycle like that, I will detect the current and voltage and plot the ellipse in 20 milliseconds. So we started this research by using finite element analysis that you can emulate physical systems using this software analysis. And we simulated turn-to-turn short circuit, like you can see the animation, please, here. So we short-circuited some turns to create this. And that can come through because of the insulation deterioration inside the transformer. You may have short circuit. Disk deformation, because of the huge electromagnetic force that may be generated during faults, you may have deviation in the winding like this, the discs. We call it disc space variation or deformation. Leakage fault is coming from the oil. Look what will happen here if you lose the dielectric ability of the oil, you may have some leakage current coming from the winding to the tank outside. Axial displacement, when you have huge electromagnetic force on one winding, you have two components, one upward and one downward. If they are not equal, you may have a movement like that. Okay. Buckling, forced buckling, again, the electromagnetic force could be in radial direction, causing buckling like that. And you have seen that in the first 2 or 3 slides. Or radial deformation, when your internal winding here will move onward to the core, causing core deformation. So we have simulated all of these faults, and we found its impact on what we are proposing. So what we are proposing here is delta V against I1. And if I selected the first fault, turn to turn fault, starting from a healthy winding, we don't have any fault here. What will happen if I have fault? Look at this. The ellipse is rotating to the right and the area is increasing. How about if I increase the number of short circuit winding, the level of fault? The area is increasing further and rotating further to the right, increasing more if I increase the fault level. If I talk about a different one here, disk space variation, starting from the healthy one, if I have a disk space variation, we'll move to the right, but the area is not increasing here. If I increase the fault, rotating further, and so on. So this one is unique than the other one, is different than the other one, which gives us a hope that the technique may work. For the next one, you can see here for axial displacement, starting from healthy, the area is not increasing, is not rotating either. But when I increase the fault, the area is decreasing. So this means the technique, I will skip this, the technique can discriminate between various types of faults. So that's how we discriminate in terms of the area of the ellipse and the rotation. So the technique is working in the first stage of our research. That's all of the faults at the same level. And you can see that starting from the healthy, the dotted one here, we have different impact from each fault on the ellipse. We have also done some practical measurements on a custom-made transformer in which you can have the winding outside. You can create a space deformation between the winding by taking these spacers out, or you can move it up or down or in radial direction. And we found that the practical results are almost typical to what we achieved in the finite element analysis. We have done that on even a bigger transformer, and we created a lot of faults, and you can see that it's similar to the impact in the simulation stage. However, again, the main point here is to standardize and come up with automated technique. So what we did, we came up with a software code based on the image processing. I'll talk quickly about this. So what we did, we started by measuring the geometrical features of the ellipse, including centroid, perimeter, internal area, major axis, minor axis, and so on. And we calculated the eccentricity. And the purpose here is, can we create a code so that I don't need any personal intervention here? So the code can tell me by what's happening directly. And that's a snapshot of the code we created. As you can see here, we are using image processing to compare the ellipse. And if there's any difference, it will tell me like this. It will give me a report, the difference in each parameter, geometrical parameter, and will tell me if there's any fault or not. For example, if they're similar like this, it will say there is no fault. In some cases, the code is confused and may give you two types of faults, that and or that. We took it to a commercial implementation. That's I'm finishing in 3 minutes. Commercial implementation. So we had this in a substation, and all what we need is access to the current input current and the difference between input and output voltage, which is any transformer should have this information. But if we don't have, we can come up with a data acquisition measurement like this, which we developed to measure the current and voltage at each side of each phase. And we have done that using a lab view, so that while you are in the control room, you can watch and see the sinusoidal waveform of each phase, voltage and current, and the proposed ellipse. Then if there's any deviation in the ellipse between one cycle and another, I told you that the technique can be performed every 20 milliseconds. The software code will tell you if there's any difference or not. Of course, the ellipse will be affected by the load. So if you change the load, the ellipse will be affected, but will be affected in a different way than what I showed you in the faults. In the faults, it was rotating and the area was increasing. In this one, it's not rotating, but we came up with a mathematical technique to normalize it, so that the ellipse will be always like this by using this normalization, regardless the load variation. And hence, any change in the ellipse will be attributed to certain fault. I think I will stop here by, that's to take home here by this very simple comparison of what I presented today. The current technique, current industry practice, is using frequency response analyzer, which is offline technique, is accurate, but it has two problems. The first problem is offline, you have to take your transformer out of service, and it's not very accurate when you have a very low fault level. The second one is it depends on personal expertise, which means you may come up with different conclusion for the same frequency response analysis signature, because it depends on the level of expertise of the person who is analyzing it. The online FRA using impulse signal can come up from natural switching operation in the network, or can come up with from lightning and thunderstorm. But this technique is not very practical, because you can't guarantee the environmental impulse signal to have enough energy and enough frequency spectrum to plot your FRA. And if you are using external impulse generator, people in utility like PLN may not allow you to do that for their operating transformer. The technique we worked on is called VI Lysigius, and the difference here is we are not conducting it at very high frequency, it's only at the power frequency, which is 50 Hertz, and this technique can be conducted in real time. However, it is still in research stage. Thank you very much, and sorry again for the timing. Sorry. Thank you.
Okay, thank you very much, Professor Ahmed Abu-Siada. It's quite very interesting presentation regarding the how to detect the mechanical fault inside the power transformer. And because the time is quite limited, so I will allow only for 2 questions from the floor. Okay, maybe anyone? If you have a question, you can raise hand, or you can speak directly. Anyone, please? Yeah, because actually I have one question.
Yeah,
so
sure.
I will keep my question after the participant ask a question.
Yeah.
Anyone from the participant? Anyone has a question? Okay. Yes, it is from Mr. Nur Afandi. Okay, please, you can ask to Professor Ahmed Abu-Siada directly, please.
Okay, Professor. Okay, thank you for the opportunity. My name is Afandi from ITS. For the online monitoring, the VI Lysigius pattern method, how if we only recognize the pattern of the voltage of the potential transformer in the power transformer, maybe we can just recognize the pattern in some period and give a threshold maybe with the statistical method. If the pattern is outside the pattern we record before, we can call it an abnormal. Is similar like that or maybe any other
You mean relying on the voltage signal only?
Yeah, maybe we can just use a voltage transformer on, or the how to say, power factor. We can maybe use that for the pattern analysis. We record, and then we maybe we can use some technique like neural network, so we can record the pattern, and then we can analyze if in the further operation of the power transformer, maybe there is an abnormal. We can compare the current situation with the previous recorded pattern. How if we conduct like that?
Yeah, that's a good question, but measuring the voltage only will not reflect the mechanical integrity or mechanical condition inside the transformer, because a change in the voltage profile or the voltage level can be due to any other reason. Could be due to the change in the load, it could be due to the change in the generation, or could be the change due to any other electrical fault, not mechanical fault. So measuring the voltage only will not be helpful in revealing the mechanical integrity of the transformer. Similar, power factor is, if you are talking about the electrical power factor, that is also can be changed due to the change in the load or a change in any other electrical component in the system. Why I selected both sides, why I selected V1 and V2 and the current here, because the area of the ellipse here will represent the losses in the core. And these losses will rely on the mechanical deformation and the physical dimension of the transformer. That's why we selected both current and voltage to come up with the signal.
Okay, Professor. So we compare the characteristic of the input voltage and current, and then we analyze it with the output voltage and current of the power transformer, something like that. We analyze both pattern, input and output.
Yeah, you can do that, and some people have published something like that. Okay, they said, okay, why we need to plot the VI and get the characteristics, get the digital signal processing or digital image processing to analyze it. If I have the raw data, V and I, can I do the same? Yes, you can do that. But again, you have to correlate the input and the output. You can't just rely on individual values, V1 only or V2 only, or I1 only or I2 only. You have to look at the full spectrum. I agree with you. And using the raw data, or you can use artificial neural network, as you said, or machine learning to give the reference or the range of normal operation. And if the values deviate from normal operation, you can report a faulty mechanical fault within the transformer. But that will not be very certain, but that's a technique and maybe simpler than the VI locus diagram.
Okay, thank you, Professor, for the explanation. Thank you very much.
Thank you.
Right, a very interesting discussion. Maybe now for the last question from the participant. Anyone with a question? Right, I haven't seen any participant raise a hand. So, Professor Ahmed, may I have a question for you?
Yeah, sure.
Okay, so I'm quite curious with this method because it's quite, it seems so simple, but it's quite very powerful because it can be done with online monitoring. So my question is, now most industrial, now they are using the nonlinear load. So what's the effect of the nonlinear current in this method? Does it reduce the accuracy or some, yes, accuracy of the detection?
Sorry, Dr. Dedet, what you said, nonlinear what?
Nonlinear load.
A nonlinear load.
Yeah.
Okay, that's again another good question. But if you look at the last slide, when I said that we normalize the load, I was talking about linear loads. Nonlinear load, the impact here will be in the harmonics and the distortion that will cause to the voltage and the current signal. That will be seen in the signal. But using a digital filter in the code we created here, we used a digital filter to filter all the unwanted harmonic and background noise. So the nonlinear load is a very good question, but yes, that will affect it in terms of the harmonics and distortion of the signal.
All right, thank you very much, Professor Ahmed, for the answer. Maybe, because we are already running out of the time, so we have to conclude the first session of the keynote speech. So please let us give the warmest applause for Professor Ahmed Abu-Siada. Thank you very much.
Thank you.
Now, I will give the time, the session back to the MC. Thank you very much.
Thank you.
And Dr. Dede Chandrariawan.
For the next speech, we have Professor Kohei Arai from Saga University of Japan. As the moderator for this speech is Dr. Roni Mardianto. Ladies and gentlemen, let's welcome Professor Kohei Arai and Dr. Roni Mardianto.
Okay, good afternoon, everyone. First, let me introduce myself. I am Roni Mardianto from Electrical Engineering Institute Teknologi Sepuluh Nopember. Today, I am as a moderator for the second keynote speaker. The second keynote speaker is Professor Kohei Arai. Actually, he is, because still my professor when I pursued my PhD degree in Japan. Professor Kohei Arai is Emeritus Professor of the Saga University, Japan. And today's presentation, the title is Current Status of Artificial Intelligence Related Research. Before Professor Kohei Arai starts his presentation, I will read his short biography. Professor Kohei Arai received PhD degree from Nihon University and was with the National Space Development Agency of Japan. Right now is JAXA. He was a postdoctoral fellow and of Natural Science and Engineering Research Council of Canada and moved to Saga University as a professor. He is now Emeritus Professor of the Saga University and the adjunct professor of the University of Arizona, Nishikusu University, and Kurume Institute of Technology Applied ER Research Laboratory. Okay, Professor Kohei Arai Sensei, are you ready? Please turn on your camera so we can see. Arai Sensei? Hi. No, your camera is still turned off.
I understand. I have the network program. The network bandwidth is not so wide, very narrow. That's why I.
Okay, we got it. Okay, and we understand. Okay, so Arai Sensei, ladies and gentlemen, because Arai Sensei has a problem with the bandwidth, so he should turn off your camera. So please accept our apologize for the inconvenience. Okay, Professor Arai, you will give a presentation on 30 minutes, and after that we will continue with the Q&A for 15 minutes. And for the participant, please raise hand and or write your question on Zoom chat. Arai Sensei, now time is yours. I will remind you if the presentation more than 30 minutes. Okay, thank you.
Okay. Before getting started, my talk, ask Loni-san to show the my slide. The 30 minutes before the getting start of your conference, I sent my presentation materials via email. to you. And just in case the network problem will not allow us to show the slide, please show the slide on behalf of me.
Okay.
Understand?
Yeah.
Yeah.
So I'm sorry because due to the poor of network, your voice is not so unclear. So my question is, the slide is from you or from our organizer, Arai? Lost? Is it lost? Yeah, I think. Okay. Back again. Okay. Yes. Okay. We already see your slide. Okay. Go ahead, Arai Sensei.
Now I will share my slide. Can you see that?
I don't know. Your voice is not so clear.
I share my slide. Can you see this?
Yeah, we can see it.
Okay. Current status of the artificial intelligence related research is my title of the keynote speech. Arai of Saga University and Nishi Kyushu University.
The slide was closed. Arai Sensei, can you hear us? Okay. Yes. We see it.
Network is disconnected. Sorry about that.
Yeah, we can see it. Okay, you may continue your presentation, Arai Sensei.
Yes. By using this slide, I'm showing this is an outline.
We cannot hear any voice from you, Arai Sensei.
How about this? And provide the impact on the artificial intelligence to our society, in particular, Industry 4.0, AI-related research history and current status, including hardware and software, followed by example of my AI research, in particular, eye contact for the crossing pedestrian safety for the autonomous driving car, and conclusion. In the middle, you can see the PC that deep learning installed here. And firstly, swing robot doesn't know how to swing. But through the trial, he learned how to swing. then it can do swing better than the human do. The next thing is a horizontal bar.
We lost your voice.
So finally, the swing robot can swing better than the human do. That is the definition of the artificial intelligence. Artificial intelligence learns itself, analyze the data, and find the property and the rule of the rules. For example, automatically identify the spam message by
It's look, we lost again your voice.
looking at lots of data, deep learning learn itself, then it should pay attention and automatically get smarter without waiting the human instructions. Let me show you the history of the artificial intelligence research. Starting from the 1960s, this is the first AI research.
Yeah, I think we lost again. So Arai Sensei lost the connection, I think. The slide is from organizer, but Arai Sensei, I think he lost the network connection. Please, okay, join again.
In the year 2009, deep learning is invented. All the artificial intelligence realized after that. This is the epoch-making year for the third wave of the AI research work. Together with the Google Cat, automatic and autonomous driving car, AI search engine, task ontology. Before that, IBM Watson open data are available. These are the history of the AI research. Different advertising the neural networks, which is included in the machine learning. And here, and deep learning is assembled to the human brain with the neurons and the synapses. If an image is acquired by the neuron in the hidden layers, indicate features of the image, and the deep learning recognize the image by using the features. That is the deep learning. here.
Yeah, I'm sorry because maybe Arai Sensei connection is not so stable, so sometimes connect and sometimes it's lost. Okay, join again.
This one here is the deep network. It's critical to the neural network. The first floor, second floor, the hidden layer inputted to the second floor of the neural network, and the hidden layer data is inputted to the third floor, fourth floor, much more higher floor. That is the deep neural network. And by using it, the deep learning can be done. And
Lost again.
cat face can be recognized from the YouTube image. Here I have the YouTube cat image, and underneath of this, there are two features of the cat face. The mechanism of the cat face is the following. Apply the deep learning to the 10 million images extracted from the YouTube. Learning 3 days with 1,000 servers.
Lost again.
Oh, that'll be fine. So that by using this node, we can extract the cat face. And if we use this node, by the way, this is the input layer and hidden layer, hidden layer, hidden layer, and hidden layer. The number of the hidden layers are there. And this one here, two nodes in the output node. The first one is a face node, human face, and the second one is a cat face. Extracted. This is the deep learning Google Cat support. Can you go to the second next slide?
Next slide.
Okay. Yeah. That is the definition of the artificial intelligence. From now on, I will show you the example of the AI.
Unfortunately, I lost again. Try to connect again. Yes, Sensei.
The slide for me. Yeah. Here
Okay.
I will see it. Starting from the fintech, financial technology, deep dream for the entertainment, healthcare, diagnostics, retail and logistics, agriculture, forestry, and fisheries, data media, education, etc., etc. There's so many application fields are there in artificial intelligence.
Looks lost again.
Provided
That's it. Yeah.
Search the term advertisement. Facebook or Google are very big two companies. The advertising by using AI. Second one is provided by Amazon and Mercari in Japan. They provide recommendation systems based on the collaborative internet. And show us the example of the AI application one. The first one is the dynamic pricing. Can be pushed with the price the AI is on. The same thing with the hotel, sports games, events. The price is determined by the AI. Depending upon the season,
Oops.
provided by based authentication at the store without cash register. Enter the store and pay after the patient authentication. The purchase the sample and checkout is automatically done. The fifth one is to register with users to connect with a friend and activate their warehouse. That is one example of the example of the AI application. The sixth one is a supermarket. The shopping cart has been boosted so that the customer flow data can be acquired and optimal product arrangements and layout can be done. The third one is and And this one is my opportunity so
Yeah, it looks like that Arai lost again. Okay, we are waiting for Arai Sensei come back to Zoom meeting. I will wait for another 2 minutes. If in 2 minutes, Arai Sensei cannot join this Zoom meeting, so I will conclude this presentation. Okay, we are waiting for 1 minute. If Arai Sensei cannot join again to Zoom meeting, so I will conclude his presentation. Okay, yeah. We apologize that Arai Sensei has a problem with the network connection, so I will conclude this presentation. That right now, artificial intelligence is very, is going up rapidly on the technology, and it's also improving the quality of life, and also shifting works occupation also. So hopefully we can hear another presentation from Arai Sensei. Hopefully if we have offline seminar, so we can invite him privately, so he can go back again to Surabaya. Okay, that's all for the presentation from the second keynote speaker for Professor Kohei. Again, we apologize for the inconvenience for the Professor Kohei due to the network connection. Okay, that's all for me. Time move to I move to MC. Thank you.
Thank you very much, Professor Kohei Arai and Dr. Roni Mardianto.
Okay, for the third speech, we have Professor Gamantyo Hendrantoro from Institut Teknologi 10 Nopember. As the moderator for this speech is Dr. Wirawan. Ladies and gentlemen, let's welcome Professor Gamantyo Hendrantoro and Dr. Wirawan.
Okay, thank you. Can you hear my voice? Is it clear?
Yes.
Okay. Yeah. Okay. Good afternoon. My name is Wirawan. I was assigned as a moderator for the third keynote speech today. Okay. Before I invite Professor Gamantyo Hendrantoro to present his speech, I'd like to first read his short biography. Professor Gamantyo Hendrantoro received a PhD degree from Curtin University of Canada, where he had been involved in the Canadian Institute for Telecommunication Research, or CITR program. And following his doctoral graduation, he was engaged in a postdoctoral research at Curtin University. Well, actually, for his undergraduate study, he studied at ITS, so he is an alumnus of ITS also. He is currently a professor with the Department of Electrical Engineering and head of the Antenna and Propagation Laboratory at the Institute of Technology Nopember. He has been engaged in various studies, including investigation into tropical millimeter wave propagation channels, study on equatorial HF skywave channels, and development of radar array and signal processing. He is a senior member of the IEEE, the 2021 under 2022 vice chair of the IEEE Indonesia sections, and the 2023 chair elect of the sections. So now I'd like to invite Professor Gamantyo Hendrantoro to give his presentation. You will have 30 minutes for presentations, and we will follow up with the Q&A. Okay, the stage is yours.
Okay, thank you, Pak Wirawan, as the moderator. Can anyone hear me?
Yes,
Okay.
loud and clear.
Okay, thank you. So I would like to share screen now. Okay. Yeah, okay, I would like to start my presentation. Thank you for inviting me to the committee, the organizing committee of ISITIA, and also the technical program committee. It is an honor actually to be presenting some results of my research as the keynote speaker today, one of the keynote speakers. And it is also an honor to be a keynote speaker among the other prominent professors that have presented their speeches before. So my own presentation will be on developments in radio and wireless communications and radars at ITS for relevant applications in Indonesia. As has been mentioned by Dr. Wirawan before, I am currently the head of the Laboratory of Antenna and Propagation, and in the Department of Electrical Engineering, ITS. Yeah. So what I will present are actually results from research done within the laboratory. So I will start with the outline. So I will start with the present situation in Indonesia. So just to give you what kind of relevance is there between the results of our research with Indonesia. Yeah. So after that, we will move on to the developments by Indonesian researchers and ITS own contributions in the fields of radio and wireless communications, as well as in radar systems, and then further ideas and conclusions, of course. So just to give you a background, characteristics of Indonesia, I think many of you, probably most of you are from Indonesia. Not sure if there's anyone from outside Indonesia this time. But okay, so the characteristics of Indonesia include several things. The first one is that Indonesia is an archipelago with thousands of islands, big and small, densely and sparsely populated, and many of which are remote with limited access to communication services. Also, Indonesia is a tropical country with a lot of natural resources and natural diversity, but also, as we know together, we have also a lot of potential natural disasters. And Indonesia also is still heavily dependent on foreign technological products, making its global role limited to being a large market, only a large market for products from the more developed countries. So local content, therefore, I think it is natural that the government is requiring now the industry to always have some local content in the products that they made. And then there are also contributions by Indonesian researchers to in the form of solutions to the problems currently we have in Indonesia. So there are a lot of researchers, many coming from the new generation of researchers, the young ones, and spread over various universities and research agencies in Indonesia, which is a good thing, very good thing. Yeah? And they are actively researching in various fields in telecommunications and radar. ITS has its own contributions in helping to solve the current problems in the country that I will present in the following slides. Yeah? So I will start first with research that we have done in IDS. We have done in ITS on long-range HF skywave digital communications, actually. So one of the less expensive way and more reliable than any other communication infrastructure for long-range communications has been provided by the nature in the form of the HF skywave in the range, in the frequency range between 10 and 30 megahertz. Those are usually the frequencies that are used by the amateur radio, for example. Yeah. So the HF or high frequency skywave can be used for communications to remote access and remote areas and islands. So in a way, this could be one of the good alternative solutions to provide communication access to our brothers, and sisters in areas that are quite remote with limited access to communication services. But before we do that, I think we need to get familiar with first with the radio channel. So we will take a look at an HF skywave channel, which is 3,000 kilometers long. This one is between Surabaya and Merauke. Yeah, so it's a link that spans from west to east, 3,000 kilometers long. And as you can see here, we have a transmitter and a receiver. The transmitter is located in Surabaya, and the receiver at that time is located in Merauke in the southern part of Papua. The objective is actually to understand how the HF skywave propagates from the transmitter to the receiver. We know that the skywave is actually a radio wave directed, or actually with a trajectory going up to the sky, to the ionosphere, and which is then bent down, or some persons usually also call it reflected by the ionosphere back to the ground. And in this case, because Surabaya and Merauke is quite far, 3,000 kilometers apart, then there could be several times reflection by the ionosphere and the ground. So for example, if we have twice reflection by the ionosphere, and between those between those two reflections, the wave is actually also reflected by the ground, then we have what we call 2F propagation. 2F means twice reflected by the F layer of the ionosphere. Yeah. So we would like to know if there is only 1F, 2F, or 3F sky waves, yeah, that propagates from Surabaya to Merauke. Yeah, so we did some measurement, and also backed up with a simulation to verify the measurement, and we found that the impulse response, impulse response of the HF skywave channel looks like this, where actually there are approximately 3 groups or 3 sets of paths or rays, propagating from Surabaya to Merauke. There are rays that are having a small delay, which means these rays are coming through the shortest paths, which is 1F. That means only reflected once by the ionosphere, and then it goes directly to the Merauke from Surabaya. While the other rays have larger delays, and this means that they come to Merauke from Surabaya through the 2F or 3F propagation modes. So we can see that the impulse response have some actually quite large components, in the excess delay of around 1 millisecond. And then if we look at now, this is also a kind of impulse response, but now instead of a function of excess delay, it is a function of the elevation angle. So how steep to the sky the wave is propagating from the transmitter antenna. So we can see here that the elevation is mostly having the elevation between around let's say 15 or 14 degrees to up to about 30 degrees. And there's only a small portion that is having an elevation angle of around 40 degrees. So if we now match this with the information about how many reflections each of them has, with respect to the ionosphere, we see that the dominant modes are actually the 2F and 3F. Here we have the 2F is between with an excess delay between 0 and 100, and and also around this it has grouped into 2 sets of elevation angles. The first one is at 12.8 to 21, and the other is 19 to around 30. And then these are so the one at the lowest excess delay actually consists of the 2F and 3F, and also the one with a little bit larger excess delay between 100 and 500 also consists of 2F and 3F. So there's only a small portion that is coming through the 4F route or mode. So in this case, that means we know that for at least for the 3,000 kilometer link between Surabaya and Merauke, the most dominant modes are the 2F and 3F. Another note that we can take for this time is that we know that for this long link, there are more than 1 paths. So there are multiple paths. So this is important when we look at the next slide. Sorry. This one. So the next one here is another study still related with the previous one, the HF skywave polarized MIMO. Yeah, so we already know that there are two characteristics waves for HF skywave, which we call as the O mode and the X mode. And these two modes are differentiated by their polarization. The X mode is right-hand circularly polarized wave, while the O mode is the left-hand circularly polarized wave. And those two are orthogonal to one another. It means that for every HF skywave entering the ionosphere, the wave will be separated into two orthogonal components, which is the X mode and the O mode. Yeah. So in this case, that means because now we see that there are two orthogonal modes or orthogonal waves, yeah, that are propagating inside the ionosphere. There is a potential, there is a possibility to actually to make use of this for MIMO channel. So in this case, we experimented with a MIMO system using two transmitters with two linear antennas, which means the antennas here, actually the waveforms generated by these two antennas are orthogonal in polarization. Yeah, although both of them are linearly polarized instead of circularly polarized. And on the other side, on the receiver, we also have two receivers with two orthogonal antennas as well. And in this case, we do the measurement using a measurement system consisting of two transmitter here and also two receivers here that are realized using USRP, an SDR platform made by National Instruments. And then we try to experiment with this MIMO channel for three different links with different lengths. So the first one is the one with the closest, or actually the shortest link between Surabaya here and Malang, which is only separated by 75 kilometers, which means because the height of the ionosphere would be about 300 kilometers. That means the skywave, the path will be almost near, or actually almost vertical. Yeah, almost vertical. Yeah. So we also we put the one in the Surabaya on the rooftop of the building of the electrical engineering department, and the one in the Malang is in the VEDC, yeah, near the bus station over there. And then we also try a little bit longer link between Surabaya and Bandung. We collaborated with Lapan in this case. The Lapan office is actually located in Bandung in the Junjunan area. Yeah, and then the third link is the long one between Surabaya and Merauke. And we come up with this result. We see that we can see that for this is actually the capacity improvement factor, which is the factor of improvement of the capacity of this MIMO system with respect to CISO, with respect to the conventional communication systems with only one transmitter and one receiver. We can see that with one hop single near vertical path, this is from the Surabaya Malang measurement, the improvement factor is about 1.8 to 1.97 from simulation, but from measurement we get 1.52 to 1.86. So it's almost two. Eh? It's almost twice the MIMO, the 2x2 MIMO system, because now we have 2 transmitters and 2 receivers, 2 by 2 MIMO, almost have twice the capacity or double the capacity of the CISO system. And then for the second one hop single oblique path, this is for the Surabaya Bandung, although it is a little bit farther between the transmitter and the receiver, but we still have only 1 hop, which means only 1 F. Yeah, only 1 F mode is there. And we can see that there is a little bit degradation in the capacity, but it's still larger, almost twice as well compared to the CISO system. And then for the longer path, the longest path actually here between Surabaya and Merauke, which have not just 1 hop, not just 1 F, but probably they don't have 1 F, because from the previous slide we learned that they have 2 F and 3 F. Yeah, 2 F and 3 F here. So that means there are multi-hop, and certainly there are multiple paths. And we see that the range of the improvement factor is quite large, between 1.49 and 1.95. So we conjecture here that this large range here is because for the NFIS for the 1 hop path, the orthogonality comes from the orthogonal polarization between the O mode and X mode. But for this multi-hop multipath, we think that the orthogonality comes from the multiple paths instead of the orthogonal paths from the orthogonal modes of X and O. Yeah. So this is what we found, and this is of course a potential contribution to Indonesia if we can realize it for digital communications to actually reach remote areas and islands in Indonesia. And then next one. So after we look at the waves at 30 megahertz, now we look at the waves at 30 gigahertz, which is millimeter wave. Yeah, and so what we look at here is the system that was called LMDS in around early 2000s, and actually this paper is also coming from 2006, so this is quite an old paper, but I will give you some updates later on that we have found very recently, yeah, with the problems of millimeter wave applications in Indonesia. But okay, so we know that radio waves at frequencies above 10 gigahertz can be easily distracted by rain, especially in the tropical area like Indonesia. So it is almost impossible to have a 30 gigahertz link operating well throughout the year in a tropical country like Indonesia. So to solve the problem, we developed millimeter wave rain attenuation model. That's the first step. We try to develop the millimeter wave rain attenuation model on 2 or 3 or several different links. So why we do that? Yeah, we want to know if, for example, a millimeter wave link is down due to the rain. We want to know if we can still use a spare link to substitute the first one. So this is a technique which is called diversity system. So we apply this model. So this model is actually based on the multivariate autoregressive model. So it is a very simple model published in 2006. Yeah. So we can actually simulate any number of links. Yeah, as long as we know the spatial correlation between let's say 2 links located with given locations. Yeah, and then we can simulate rain attenuation on those 2 or 3 or any number of links. Yeah, for example, in this case we have 2 links. We can simulate the rain attenuation on the 2 links. Yeah, as a function of time. Yeah. So this is another result using, which is actually obtained using applying the model, the spatial model of millimeter wave rain attenuation in tropical areas. So this is the scheme that on the right side of the slide was reported in 2009. So this is the scheme where we apply diversity system for a user equipment. This is let's say a user with a handphone, for example, between two base stations, or actually there are 4, but in this case we assume that there are always only 2 base stations that serve the user. So this was from 2009, a result of one of our PhD students, which is about 1 decade before we have 5G. So at that time, this kind of scheme probably is still impossible to implement, but now we have what we call coordinated multi-point, made possible by Cloud Run, and this technology can actually realize it. So in this scheme, we know that depending on the position of the user of course can be here, can also be anywhere else in the square area. We can provide a diversity scheme for different position of the user. So what we found actually is the one at the bottom here, with for a number of BTS base stations, covering a square area like this, we can divide or segmentize the area into 2 regions, 2 different regions. Region number 1 and number 2. For the region number 1, we don't need any effort, like for example coding or adaptive coding or even diversity. We just need to use a fixed modulation. This is applicable for the region number 1, but for the region number 2, which is quite far from all base stations, we need to have an adaptive modulation. So this is a combination between diversity, adaptive modulation, and also adaptive coding, I think. So these are all what we found at the time. At around the same time, I guess this is from 2010. We also have a collaboration with a researcher in Darmstadt. Through a double degree program at the time. Here we assume that there are a lot of cells here, square cells, in which the areas are divided into those with vertically polarized radio waves and horizontally polarized radio wave. And there are some possible interfering base stations with respect to the desired base station. So the desired base station here is BS1 and BS2, and the one in the middle here is the user, or the subscriber. So this research is attempting to calculate the capacity, the Shannon capacity experienced by the user. Now we can see here that in the condition without rain, the MIMO system, of course, will increase, will have an increased capacity compared to the CISO. The CISO here means there is only 1 base station serving the user. So the MIMO, the one with the 2 base stations, have twice higher capacity compared to the CISO. And even when there is rain, there are still some capacities remaining in the system. Not unlike the case with the CISO with only 1 base stations. When there is rain, then the capacity goes goes down to 0. So that means it cannot be used for communications. Yeah, so here again, this is from 2010, approximately 10 years before 5G. We already have this idea. This is just an update that in actually this year, starting from last year, we started to look at the statistics of millimeter wave and terahertz attenuation by tropical rain, and this is this is for 5G and 6G communications. Yeah. So what we do here, we want to look at how much rain fade margin that we should provide in Indonesia, yeah, when we want to apply 5G base stations, yeah, with links with a variety of lengths, yeah. For example, in this case, we want to know if there is any difference between 3 different places, for example, between Kota Tabang in Sumatra, Surabaya, and also Surakarta. Yeah. If we would like to have the same reliability or availability, let's say at the level of 99.99%. Yeah. So we learned from here that, for example, for a link of 250 meters length, yeah, the rain fit margin for an outage of 0.01% is different. Actually, there are 3 different values, 3.57 and so on. If we want, let's say, a rain fit margin of only 3 dB, 250 meters length cannot be achieved. Yeah. So what we have now is just probably around 200 meter length links, yeah, millimeter wave, and we are talking about millimeter wave at around 30 gigahertz. Yeah. So it's around 26 or 28 gigahertz bands. And we see here that even for the 200 meters, there are some location that the rain fit margin is a little bit below 3 dB, but in Surakarta, for example, it is a little bit higher than 3 dB. So actually, we have results for more locations in Indonesia, and actually we can see that the rain fit margins requirements for different cities or different locations might be different. Yeah, so that means the design of millimeter wave links in different cities in Indonesia might require different rain fit margin when we are doing the link budget. Yeah, so that's the finding that we got. On the right side now we have the experiment or the simulation actually that we have for terahertz outdoor terahertz links. Yeah, and we know that terahertz will be used for 6G. And we apply the multivariate autoregressive model that we have talked about in the previous slide. And we also learned here that we see here that for 1 terahertz wave, the attenuation by rain is very large, and it goes to if we look at 20 meters link, yeah, it goes already up to 4 dB. Yeah, when we try to get 99.9999% reliability as required by 6G. Yeah, so it is very tough actually to achieve very good reliability for terahertz 6G. Yeah, if we apply it in tropical areas like Indonesia. So this needs further research, yeah, to find the solution for this problem. The next one here is 5G indoor base station antenna design. So probably everyone is asking why this is important. What is the relevance of this with Indonesia? As we know that indoor base stations is going to be used in buildings like malls, shopping malls, hospitals, university buildings, office buildings, and so on. Yes, there are so many of them in Indonesia, and That means if we want to have as many as possible local content in Indonesia, then 5G indoor base station might be one of the possible product that we can make in Indonesia, and we can have a mass production of that, for example. So so 5G means what is the challenge in this 5G indoor base stations? So if it is used for 5G, then it means that the bandwidth should be wide enough, to meet the requirement of 5G, and it should also be capable of reaching as much area within a room, for example, or a building, as much area as possible that reflects signals from users, because this kind of base station might be for a very large building like shopping malls, might also be using a kind of, let's say, MIMO systems, and with beamforming. So it would be a kind of MIMO with beamforming. So in this case, the structure usually is composed of subarrays, and so here this is for example, if this is the room, the indoor situation looks like this, for example, then we want to have subarrays with beams that reach every single corner of the building, and to do that, one of our students designed this kind of antenna structure. So every rectangles here is composed of a subarray, actually. So this is a subarray. One square here is a subarray. So if we want to zoom in one of this square, this will look like the one on the right. And this is just one type of the subarray. This is a 2x2 subarray. But actually, in reality, the design involves also some 6x2 subarrays, 3x2 subarrays, and so on, to meet the requirements of these beams. So that's the challenge of this antenna design. So the problems now include the insufficient bandwidth, because 5G requires sufficiently wide bandwidth, and the mutual coupling between elements. So here we have 2x2. So the elements actually is this. This is one element. This is another element. So we have 4 elements here in a 2x2 structure. 2x2 structure. So how to get the wide bandwidth? It is finally solved by using what we call parasitic patches. So if you look at more closely here, the one in the middle here for this element, the one in the middle here is the one that is fed. But the others here are not fed. So the others are the parasitic patches. The parasitic patches. So we found that the more parasitic patches, the larger the bandwidth of the element. So now we are trying to design a subarray as a phased array, consisting of 4 elements, in a 2x2 structure, and we found that if we compare these 3, the one in the bottom is the one with the largest number of parasitic patches, and it gives us the widest bandwidth, the widest bandwidth. Okay, so this is for the 5G indoor base station. This is a little bit different now. This is not about wireless communications, but about radar. I think my time is up, but I will move on. I will go on as long as the moderator does not stop me. Okay, so this one is actually for a radar. And as before, why this is important, why we would like to develop this, I think the reason is that because we want to increase the local content. We have very long coastlines. Indonesia has a very long coastlines. Every island has a coastline of itself, but we have thousands of islands. So the coastline is very long. Yeah, the total coastline, and those coastline needs surveillance, of course. And one thing that we can do to help our country, Indonesia, is of course to develop as many radar as possible. This one is a technique actually to develop radar based on a phased array that can be scanning electronically. Yeah, and the novelty in this phased array is that because it is composed of subarrays, yeah, and the subarrays have many different forms. So the ones on the top here are different subarrays. So this is the first type of subarrays having only 2 elements with different currents, feeding currents between the two. And then the second one has 3 elements with also different feeding currents. And then we have also the one with 5 elements, but there are 2 feeders here. Yeah, there are 2 feeders. And then we have the multi-elements subarray. There are 2 types of them. This one is for the center of the array, and this one is a little bit to the edge of this array. And these are the horizontal subarrays. We have also one type, actually 2 types of vertical subarrays. Yeah. With 3 elements, yeah, with also different feeding current. And these subarrays can be used together to compose a full phased array like this. Yeah, so we can see here, for example, this one is the vertical subarray. Yeah, so there are how many here? 1, 2, 3, 4, and so on. Yeah, vertical subarrays that are positioned approximately in the center of the phased array. And let's say the 5 element subarray, this one is located at the edge, yeah, both in the left and the right edge. Yeah. So beside that, we also apply what we call the amplitude tapering. Yeah, this one is aimed to decrease the side lobe level of the phased array. Now, so the question is, of course, what is the function of each of these subarray? Do they have different functions? Yes, they do have different functions. For example, subarray number 1 here, this one, subarray type 1. This one is with a center feed with a 2-way power divider because they have 2 elements. And the function is actually to compensate scan loss. Yeah, the scan loss here happens because the total radiation pattern of a phased array is influenced by the element pattern. Yeah, so the element pattern is usually in the form of a cosine. So when the this is the scan angle. Yeah, when this is the radiation pattern. When the phased array is looking at to the front, which is what we call broadside, yeah, broadside direction, then it is scanning to, let's say, to 60 degrees, so from 0 to 60 degree. Usually the gain is reduced, yeah, is decreasing, yeah, and that's because because of the pattern of the elements. Yeah. So in this case, we try to design the phased array with the help of the subarray to compensate that scan loss. So as a result, we can see from these plots that when we compare the blue, green, and black ones here, the 3 patterns for different scan angles, we can see that their heights, yeah, their magnitudes are approximately equal. So that means in this case, this phased array is capable of successfully compensating the scan loss. Yeah. So but why is this important? So we will have a look at the second type of radar systems that was developed by another of my students. Yeah. So this is what we call MIMO radar, the ones with a separate transmitter and also a separate receiver. Yeah. In this case, we have here, for example, in the transmitter we have several waveform generators, and in the receiver we have digital signal processors. Yeah. So in this case, we can have multiple input, multiple output radar, where multiple output comes or actually counted from the number of waveform generators, digital waveform generators, and at the receiver, the number of receivers is equivalent to the number of the digital signal processors. Yeah. So in this case, usually we can apply this using the software-defined radar platform. Yeah. So that when using that, we can actually be playing with the waveforms. We can change the waveform so that we can find the best one for use in this MIMO radar. So because of this use of waveform generators and signal processors, we can have different combinations of radiation patterns between the transmitter on the left side and the receiver on the right side. Yeah. So we can have the transmitters working as a phased array, as one phased array. That means the radiation pattern will be like this: only one beam, yeah, with a high gain and limited beam width, yeah. But for example, if now the receiver, the digital signal processors are working independently one another, yeah, one another, and so they are actually non-coherent, then we can have actually the receiver system consists of several receivers with, let's say, omnidirectional antenna each. Yeah. We can also have something like this. Yeah. So it is actually a combination. Yeah. And the last one here is actually a combination. In one side, in transmitter, for example, we can create phased array not by using all available antennas, but only using some part of the antennas. Yeah. So that now we can have more than one beams like this. Yeah. So now the problem is, of course, to find the combination that is optimal for different applications. Yeah. So we arrive at this curve actually where we can optimize the performance of the radar based on three performance indicators. The first one is the signal to interference ratio. The second one is the transmit and receive gain. So this one is about the gain of the antennas at both sides. And the other one is signal to noise ratio. Yeah. So and we can see here that these three performance indicators have different peaks. Yeah, have different peaks. So now it is our task when we design a radar using this structure to find the most the optimal point. Yeah. So where is this applied? We can apply it for, let's say, this is the bird radar. Yeah. Usually it is located. It is used in let's say an airport, an area around airport where birds can be hit by an aeroplane, for example. And it's not just it will kill the bird, but also it will endanger the aeroplane as well. So that's why a radar that can detect the presence of birds is quite important. Yeah. And also it can also be used for a vehicular radar. Yeah. Now this is a
excuse me, I have to interrupt. You have used up the allocated time, including the
Okay, question
questions.
time.
Could you please just move forward and
Okay.
up to your conclusion? Thank you.
Okay, thank you. So just mentioning that this is the latest type of radar that we have been developing, and this is still going to be defended by our student on July 26th. There will be an open Zoom at the time that everyone can attend. Yeah. So I can share it later on. Yeah. So the conclusion. Yeah. So several contributions have been made by ITS in development of wireless communications and radar. And this includes digital HF skywave radio communications for remote areas and islands, mitigation of rain attenuation impact to millimeter wave systems, antennas for indoor base stations applications, multi-beam MIMO radars for various applications. So in the field of wireless communications and radars, there are still a lot of potential contributions that can be made by Indonesian researchers. And as we can see before, any contribution can be both scientific and applicative or practical. Yeah. So development of new solutions might require collaboration among universities and research agencies, and implementation stage of these types of inventions require collaboration between researchers and industries. So I guess that's the end of my presentation. Thank you, Mr. Moderator.
Okay, thank you, Professor Gamantyo. Yeah, since I have told you before that we have used up all the allocated time for the presentation and question and answer, we have to conclude this your presentations. And because it seems that the organization committee will rearrange for the to catch up what has been missed from the previous presentation from Professor Arai from Japan that would like to continue his presentations. So thank you very much for your presentation on behalf of the organizing committee. It's very quite interesting results and congratulations for the achievement to your research work and including your team and your laboratories. And please, for the all attendance audience, we will give big applause to the Professor Gamantyo Hendrantoro presentation. Okay, thank you very much. And of course, for the all audience or participants that are interested to the some parts of the Professor Gamantyo presentation, you can always give your questions or comments on the chat rooms, or later on maybe you can always contact him or his laboratories. And we still have 2 days time for the conference. Yeah. Now I will return the stage to the Master of Ceremony. Okay, thank you.
Okay, thank you very much, Professor Gamantyo Hendrantoro and Dr. Wirawan.
Because of previous technical difficulties, we will now continue with Professor Kohei Arai's keynote speech. Again, as the moderator for this speech is Dr. Roni Mardianto. Ladies and gentlemen, please welcome again Professor Kohei Arai and Dr. Roni Mardianto.
Okay, thank you, Master Ceremony. I will check whether Arai Sensei already here or not. Arai Sensei, can you hear my voice?
Yes, of course.
Okay.
Yes.
Okay. Glad to hear your voice again. Okay, Arai Sensei, you may continue your presentation, and I will share my screen, and I will show your presentation material. I think for the last is page number 10. Is it right?
You're right.
Okay.
I
Okay.
just finished
Okay, now I get
definition of
better
the
voice
AI.
from you. Okay, now is a better voice than the previous one. So, sorry. So, okay, you may continue your presentation. Go ahead.
Okay. The next thing that I have to do is to show the example of the AI applications. Second one, please. Yeah, there are so many application fields, starting from the fintech, financial technology, etc., etc. There are so many application fields of the artificial intelligence. Next one, please. This is the example of the application of the one. The first one is provided by the Facebook and Microsoft and Google's search terms for the advertisement. These three companies are huge company for advertisement. And the second one is the provided by Amazon and Mercari. They provide the recommendation system based on the collaborative filtering so that the user's preferences are known through the learning process with the AI. Dynamic pricing is a very, very common. By using AI technology, we can determine the price of the airplane ticket and the hotel, sports games, etc., etc. These prices are determined by artificial intelligence, followed by Amazon Go, face authentication at the store, so that we can purchase the something and without pay anything. But after the face authentication, we can check out automatically the Foursquare using the GPS location information, real-time advertisement through the website and the mobile applications that allow registered users to connect with a friend and update their whereabouts. So a location base can be done. Next slide, please. The example is the following. The AI application number 2, supermarket. The shopping cart has a sensor so that we can know the location of the shopping cart in the supermarket. The customer's flow can be acquired by using the data. We can find out the optimal product arrangement and layout. The next one is the Uber and the Lyft. They are the company for their ride share. Ride share price can be determined by artificial intelligence. Time and place and number of the users. Depending on these factors, the Uber, Lyft, ride share price can be determined. SNS data identify the product issues, and the product development and the content creation can be done with the artificial intelligence with SNS data, etc., etc. For instance, the content generation, MIT, Massachusetts Institute of Technology, if I input some words, and then the moving picture can be created by using the MIT systems. Next slide, please. This is one of the example of the AI application. We can detect the person with the probability. Next slide, please. We can also identify the person, buses, and cars. Some other object can be acquired with the artificial intelligence. Next slide, please. Next slide. Even for the human face can be detected with their motion with probability angry, happy, neutral, sad. Such an emotion can be recognized with the artificial intelligence. These are moving picture, but time is limited and narrow bandwidth of my network. I cannot show you the moving picture. Next slide, please. Sorry about that. The next thing I would like to show you is the impact of artificial intelligence to our society. Currently, we are entering the Industry 4.0 era. Next slide, please. In the Industry 4.0, big data analysis is a big issue. Blockchain, IoT, artificial intelligence, machine learning, deep learning, and reinforcement learning, machine intelligence. These are the items required for the Industry 4.0. By the way, big data is called oil in 21st century. That's important data quality. Next slide, please. Right-hand side, you can see the important issues of the Industry 4.0. On the other hand, right-hand side, you can see the Society 5.0. The Japanese government is now promoting the Society 5.0, a system that combines cyberspace, virtual space, and physical space. It's a real space at a high level and a human-centered society that solves economic development and social issues. This is called Society 5.0. Next slide, please. I'm one of the AI researcher, and everybody asks me, their courtesy is on. Does AI overwhelm human natural intelligence? It'll be occurred in 2045, Kurzweil said, and it can be realized, I believe. Next question is, does AI take human work? 46% of the occupations in 32 countries in OECD is replaced to the AI. So AI take the human's work. And 210 million of the people will be suffered from the AI. They are losing their job. No. It's not saying, I'm not saying this. OECD says in the year of 2030, 210 million people will be suffered from. The third question is, how does society change in Industry 4.0 and Society 5.0? It's a very important issue. in the Davos conference theme in year 2019. The fourth question is, what impact are suspected by AI for our society? Now I show you. Next slide, please. Artificial intelligence related research history and current status, including hardware and software. By the way, the fifth items, example of my AI research, eye contact for crossing pedestrian safety in the era of the autonomous driving car will be suspended. I will quit to show the example. The next thing I will show you is that AI-related research history and the current status. Next slide, please. Nowadays, big data is an unstructured data set flood every day, so that the big data analysis, big data acquisition, and storage, analysis, display, visualization, and integration of the big data are current research issues. Cloud computing and fog computing is the second issue. Machine learning becomes affordable. Deep neural network approaching the human intelligence and hardware advantage, advanced GPU, FPGA, TPU, TensorFlow unit, MIT Iris, Google TPU version 1. These are
You are mute, Sensei. Please unmute your microphone.
Can you hear me?
Yes. Okay. You may continue.
Next slide, please. I will show you the example of the IBM Watson. They have the CPU core of 2880 and the main storage capacity, random access memory, 15 terabyte, and the circulation speed, the 80 trillion times per second. Such a huge computer is the IBM Watson. Next slide, please. AI hardware and software. As I mentioned before, TPU is now available. TensorFlow processing unit can be purchased by the Google. Google's machine learning chip is already developed. AI machine learning specialized hardware is now available. Google TPU is a famous one, and as well as the cloud TPU. And the use JIT, GIT is help you track a different version of your code and collaborate with the other developers for code version control system is created. The written in the Ruby language on Rail and Erlang, maintained by GitHub, based on the San Francisco, California, USA. Next slide, please. These are current status of the AI hardware and software. Now, I will show you the risk of AI. AI is not perfect. AI has the three major problems. One is the granularity of the artificial intelligence. So very weak deep learning artificial intelligence is very weak against noise. If the training data set has the noise, then the artificial intelligence output data is damaged. Here I have one of the example dolphin attack so-called that allow you to operate the voice assistant such as Siri or OK Google at the frequencies that are inaudible to the humans. The second problem is a black box. Accountability is needed for the artificial intelligence, but the artificial intelligence itself is a kind of black box, so that the unknown logics in the black box, we cannot clarify the logic. That is a problem. The third one is a bias problem. If the training data set has a bias, then artificial intelligence made mistakes. Next slide, please. These are major risks of artificial intelligence. So I will the future AI-related research directions. One direction is to overcome the aforementioned AI risks, three risks. How to overcome these risks is one of the research directions. The second one is the region-based convolution neural network, R-CRCNN. The YOLO Vision 6 and beyond is famous as the region-based CNN. Fast RCNN, faster RCNN, SSD, and mask RCNN are already developed. What's next? That's the question. The third direction is GAN, Generative Adversarial Network. From the noise, you can create some image and compare to the real image and discriminate and create the fine resolution of the image with the super resolution, and from the electromagnetic wave acquired satellite data to optical sensor data. Such image conversion can be done with the GAN. CGAN is famous. Cycle GAN, pix-to-pix, high definition, and FG GAN, DC GAN, and SISR, super resolution, etc., etc. These are the third direction of the future research work. And the fourth one, final one, is the biggest issues. General purpose artificial intelligence. Research is being conducted at various research institutes around the world, including Japan. In Japan, the Artificial General Intelligence Study Group, I'm one of the members, is now taking the opportunity to create the general purpose AI. whole brain emulation, and whole brain architecture. These are the target of our research work. Next one, please. Next slide. This is a GAN architecture. As I mentioned before, discriminator, generator, generate the fake image by using the noises and compare both and real or fake discriminator defined. And this is the architecture. Next slide, please. Next slide. Thank you. In conclusion, AI is effective in improving the quality of life, shifting the work occupations, reforming working style, and eliminating the storage of working labor force. Artificial intelligence does not rob humans of their job, but humans left them do their jobs to secure human resources. Move to the job shift that only human can do. It is the final decision making can be done by human, and the responsibility can be taken by human, not the AI. There are so many applications field for AI, and please care about the risks of artificial intelligence and overcome the risks. The future research directions and the symbiosis between human and AI under the OECD principles. Next slide, please. This is the final one. OECD principles. Using AI, transparency, user support, and controllability, security itself, privacy protection, ethics, accountability, in particular for the accountability. To maintain the accountability, we need to white box from the black box. That is my conclusion, and always see the recommendation of the AI utilization. Thank you for listening.
Okay,
Thank you for participating.
Professor Arai. I think very interesting topic. AI is always interesting topic, and Arai Sensei, I want to inform you that ITS purchased supercomputer for AI. It's called NVIDIA DGX. Yeah, we purchased it. So we have a supercomputer for doing training for the AI. Yeah, the AI in ITS. I hear also in ITS we will open new study program specialized for AI also. Yeah, it's very interesting. Okay, we will continue to we will continue to question and answer. Please, any participant want to, if you have a question, please raise hand or may write note in Zoom chat, please. Any question?
Before that, I have a question to you.
Yes. Yeah.
The ETS has the research group on the artificial intelligence.
Yes, of course. We have a research group. Yeah. Professor Mauri Dihari Purnomo is one of the our professor that the research in AI, artificial intelligence.
Okay.
Professor Mauri Dihari Purnomo, and he has a lot of PhD student that also working on AI also.
Okay. I like to make a collaborative research work with
Yes,
you,
of course. Okay.
ETS.
Okay. Yeah, I will contact Professor Harry and discuss it, and hopefully we will have a good collaboration between you and Professor Mauriti Heri Purnomo. Okay, I will, inshallah, I will contact Professor Mauriti Heri Purnomo and introduce you. Okay, Arai Sensei. Okay.
Yes, please.
Yeah. Okay. And so, is there any question from participant from the audience? Yeah, I think AI is very interesting topic. Any? Please raise hand or make a note on Zoom chat. Is there any? Yeah. Okay. From Mr. Sadiwa, maybe you can just make a question directly to Professor Arai. You can unmute your microphone.
Okay.
Mr.
Thank you.
Sadiwa, Wicaksan. Okay, go ahead.
I have a question for Prof. Arai. As you said that the AI is the black box method, yes. So what you have a suggestion approach to find out whether the method we implement is correct or not? Because as you said that AI is the black box method. Maybe you have like that. Thank you, Prof. Arai.
I'm still working on the black box problem, black box issues. One of the idea is come up with my brain is that second stage of the AI. So AI can be divided into a couple of the stages. The first stage, second stage, etc. And then the intermediate result of the first stage output can be input to the second stage of the AI. Number 2, deep learning number 3. And we know the output of the deep learning number 1. You know?
Yes.
And also, we know the result of the second stage of the deep learning. And the final one, we know. That's why if we can explain the logic in the deep learning, total deep learning, if I use the only one deep learning, then we don't know the logic. But if the deep learning can be divided into 3 stages, then we can check the first stage, second stage, and third stage. That's why we can explain the logic of the first stage and logic in the second stage and third stage. That is one of the solutions to overcome the black box issues. Make clear? Did I?
Yes, it is clear, Prof. Thank you.
Okay, thank you, Mr. Sadiwa, for excellent question. We can use 3 states of in deep learning, so the AI will not be a black box again. Okay, thank you. Is there any question from any from participant or audience? Is there any? No? Okay, if not, my question is from me, Sensei. Yeah, as you said before, that OECD principle for AI it consists of transparency and user support, and then controllability and security and privacy protection, ethics and accountability. Yeah. So if somebody, because AI can, the use of AI can be have advantage or disadvantage. or maybe for the extremely case, it can be harmful people also. So my question is there any organization that control the use of AI? That AI will give benefit to society and not will give a negative impact to society.
The controllability is a big issue for the every countries, not only the OECD countries. There is no control committee in the world about the utilization of the AI. That is the problem. And these 8 principles, in particular the accountability, we have to maintain. One of the features of the black box of the AI has to be white box. The security and privacy are much more important issues here. Security and privacy and ethics we cannot control, and the user support we need, and transparency in order for the accountability we need. The artificial intelligence has to be transparent, such and such. So I do care about the all these OECD principles.
Yeah, okay, thank you, Arai Sensei. Due to time is limited. Thank you so much for very interesting presentation. Even in the beginning, we have a problem with network connection, but for last presentation, I think it's very good quality for. Yeah, we got a very clear voice from you, so we got 100% the content of your presentation. So I think it's very interesting, and thank you so much for your time today, and hope to see you again. Long time not to see you. I think we met on Juanda Airport 3 years ago, and I hope that we still have a chance to meet offline, whether you go to Indonesia or I go to Japan. Okay, thank you so much, Arai Sensei, for your time. And okay, thank you so much, and give applause to Arai Sensei. Okay, thank you so much. And time.
Thank you so much.
Okay, go to Master of Ceremony. Thank you.
Thank you very much, Professor Kohei Arai and Dr. Roni Mardianto.
What an inspiring lecturers. Thank you very much for all the speakers and moderators for today. We are almost at the end of today's session. Next agenda, the head of the Department of Electrical Engineering ITS will give a closing remark. Please welcome Dr. Dede Chandra Riawan. Time is yours.
All right, thank you very much, MC. Thank you very much, MC. I think it's quite a long day having our 3 keynote speakers with us today. But before we close the session for today, I would like to make some remarks on what we have learned from the keynote speakers. First, from the first keynote speakers, Professor Ahmed Abu-Siada, we have learned that simple Isaiah's method can be used to avoid a catastrophic failure on the power transformer. I think it's quite interesting because the simple method can be used to solve a quite complicated problem. I think it is quite inspiring for all of us who have done in electrical machine research. And from the second keynote speaker, Professor Kohei Arai from Saga University, Japan. Even though we have previously we have technical difficulties, so the presentation is quite interrupted. But finally, yeah, we can listen to the complete presentation from Professor Kohei Arai. And yes, we have to admit that AI, the artificial intelligence, is entering our daily life because maybe all of the participants realize that our smartphone maybe in the next 5 or 10 years maybe smarter than us. So we have to be careful with this phenomenon. And for the third keynote speaker from Professor Gamantyo from ITS, we have learned that yes, the tropical area such as in Indonesia, it has quite a unique characteristic in wireless communication quality. We have seen that the rain is affecting the quality of the wireless communication, and that's why Professor Gamantyo also stated that the research is still open for a researcher to do research on the antenna and radar design, especially in tropical areas such as in Indonesia. And therefore, I would like to thank to all the keynote speakers for the day. And of course, we have to thanks to Rector of ITS and also the Dean of Electrics for supporting this conference. And also for the participant here, because I see that many participants here are postgraduate students. So it is quite a good sign that our PhD student, our postgraduate student, is showing the enthusiasm in following this conference. And my message to postgraduate student, keep the spirit on and keep working on your research and study. And good luck for the all of the postgraduate students who are attending this conference. And last but not the least, I would like appreciate the work from the organizer committee of ISITIA 2022 because the organizer has done a very challenging job to implement this conference in a virtual conference. Hopefully next year we can have the on-site conference, so we can interact. The interaction is more is getting better, and all of the knowledge and the idea can be transferred among the participants. And for the closing statement, I would like to appreciate all of the participants and all of the attendance today, and for the reminder that we still have a second day session for tomorrow, and tomorrow will be the all of the session will be a parallel session of the technical session for tomorrow. And have a good evening and have a good rest and stay safe, and I will see you tomorrow in the second day of conference. Thank you. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much, Dr. Dede Chandrariawan.
Our last agenda is the virtual photo session. We have around 3 pages of Zoom profile pictures. The committee will help take our photo. Please turn on your camera and smile. And please hold your pose for all the pages. I will give a signal to take a picture of us. Okay, now for the first page, get ready. 1, 2, 3. And the next page, 1, 2, 3. And for the last page, 1, 2, 3. Okay, thank you, everyone. Ladies and gentlemen, now we have come to the end of the keynote speaker session. I'm sorry for any mistakes and technical difficulties. Thank you, everyone, for joining today's ICTS session. May what we had conducted will be useful for us. See you tomorrow. Goodbye and have a nice day.
Recording stopped.